Cool. Hello everyone. Thank you so much for joining in. It's my privilege and my ultimate pleasure to be here today. My name is Ameen Altajer, and I'm a Google developer expert in machine learning. So I'll be taking you today on a tour to understand how machine learning works. We're going to take a very small tour in order to understand how the whole thing works from A to Z without really focusing too much on the technicalities, because this is going to take more than 1 hour. But nonetheless, hope you enjoyed, and let's go ahead. Okay, so I'm not going to spend a lot of time on myself. So my name is Ameen Altajer. If you guys are interested in hearing about what I do, you can always check out my website, which is ameenaltajer.com. And yeah, I have my Instagram as well, and I have my YouTube. So guys, check them out, and I'm sure you're going to be happy. So yeah, a couple of our clients that we worked with across the years, we work with governments, banks, and a lot of businesses that really want to rely on machine learning and artificial intelligence as well. And we do also have our own chatbot that we've done, which is basically a chatbot that works in-house and that really works really, really well, especially when you're talking about banks, for the kind of institutes that are really kind of careful about, putting their data on the cloud. So Calvaria is here to help. And that's pretty much it. Okay, so for today's session, I want to really touch on four important points. The first one is I want to give you the status quo of machine learning so you can understand what you can do with it and what you can do with it as well. And then we want to focus on typical problems and flows that you can use machine learning in order to solve it. And then we're going to have a very quick roadmap somehow for the brave in order to really adopt if you intend to use machine learning in your projects, whether your projects are commercial or just strictly personal. And by the end of it, we're going to open up for QA if somebody is here who's interested in, asking a couple of questions. All right, cool. So let's talk about the status quo first. What's happening in the world of ML? Now, if you look into those images here on the right side, a lot of people would really freak out when they understand that all of this is actually the work of machine learning, believe it or not. So there's a machine learning model, and when we say a model, it's basically, think about it as a program. It's a complicated formula, and it allows you to generate faces, or let's say fake faces in this case. And as you can see, these kind of faces that you see on the right side, it's so complicated to really tell if these are true or these are really real or just fake. It's so hard to do that. And the reason is this machine learning model, or in this case, this artificial neural network is so good when it comes to generating these kind of fake faces. And I can't blame you. So this is one of the things that you can get with the current status quo machine learning models. And so if you really want to define artificial intelligence, it gets very hard. The reason is there's a lot to it. The scope is really big. But as let's say, brave endeavor, if we wanted to define it, I'd say that artificial intelligence is all about artificially depicting cognitive skills. And that is something really important because we humans tend to take things for granted, especially if we're talking about cognitive skills. So things like learning, problem solving, and all of these kind of human skills that we have and enjoy, we take for granted. We don't understand how it's implemented and the difficulties when it comes to really reproducing the same kind of skills. But if you try to program an application or a system that can, kind of take advantage of those things, you're really going to be facing those technical challenges that are going to really let you appreciate the kind of human intelligence that you have and enjoy. So a lot of people think that artificial intelligence is pretty new. So even the word new is really elastic. There's a lot to it. But generally speaking, artificial intelligence is now probably 70 years old. It's not really that new. 70 years is not, that much of a time. It's not really that long of a time. But if you look at it in terms of the universe, but however, if we're talking about about tech revolutions, 70 years is a lot of time. And so if we think about it, it's not really brand new. It's just 70 years ago that we had all this happening. But in the last 10 years, maybe, or the last 15 years, things started to cook and a lot of people started to get really, really interesting stuff. So what we want to focus on today is we want to understand that, why is it that a lot of people think that this is new? And the reason is we've got two main big drivers for this. The first thing is, in terms of the computational power, you got to understand that machine learning is really hungry when it comes to computational power. It takes a lot of computational power, a lot of CPU time, a lot of CPU power in order, not maybe CPU is not the right word now, but let's say a lot of computational power in order to get things working, a lot of chunking to happen. And so with the cloud, you get all of that to happen. So a great example is for, GCP, Google Cloud Platform, or Amazon Web Services, or even Microsoft Azure. All of these services, with a click of a button, with simple, with the access that you get with your fingers, you can basically book a huge amount of infrastructure, a large amount of infrastructure in order to do computational stuff on your end. And the second reason is we humans are really good when it comes to accumulating data. So a great example here in this case is that we humans, if you look into history, we have data on plants, we have data on wars, we have data on computers and games and every single thing that you think about. And so all of these things combine the super computational power that is abundant now and the huge repository for historical data present a kind of reboot to artificial intelligence. And this is why we have a new phase two. In order to understand what machine learning does, which is a subset of artificial intelligence, let me take you through two of what's happening. You see, with traditional programming, what you do is you take your input data, okay, and then you have to tell somebody to implement a sort of mechanism to take that input all the way to the output. So somebody has to have that know-how of understanding how to transform the input all the way to the output. And it's not an easy job. It is extremely complicated. This is why you need business analysts. You need to have engineers from the field, knowledge experts, subject domain experts again. All of these people will tell you exactly how to transform the stuff that you want from the stuff that the stuff that you have until you get the stuff that you want. Now, with machine learning, you don't need to do a lot of programming to begin with, and that is the honest truth. In machine learning, the flow is really straightforward. In order to play with machine learning, you have to have input, the kind of things that you have, and then you have to present the output, the things that you want, and then all of a sudden, this machine learning magical box, this black box that we call neural networks, is going to transform that thing from the input all the way to the output, and it's going to generate the code for you. And let's put a small asterisk here on the word code, okay? So that black box that we call the neural network is going to take her from the input all the way to the output, which is a beautiful thing. And so by the end of it, you get this thing that we call a model. And a model is just a complicated formula that takes your input all the way to the output. Okay, so maybe showing examples is going to be a really good aid here in this kind of thing. So imagine you want to build a program that can tell the difference between cats and dogs. Now, if you want to do that on your own, as a traditional programmer, you're probably going to just pull your hair out because it's extremely difficult. Reason is you have a lot of variance. You have too many people. You've got too many challenges. You've got too many technical challenges. So it's very hard for people to write a complete program in order to do that sort of differentiation. I mean, I'm sure you have cats with whiskers. You have cats with short whiskers. You have dogs with different colors. You have different poses, different backgrounds. So it becomes extremely difficult to find, that snippet of code that can really unify the whole experience. Now, with machine learning, the flow is much easier to tackle. The reason is you have images of cats on the left and you have images of dogs. So your whole purpose, your whole goal as let's say somebody that wants to tackle that problem is to just solicit those kind of images. You're going to have your cats on the left and you're going to have your dogs on the right. And then you can actually put it in this small box that we talked about that we call the neural network, quote unquote, and we're going to get to that in a second. And by the end of it, you're going to have this model, which is this magical thing that's going to take you from the input, which is the image in this case, the image of the cat, all the way to the output, which is the differentiation. So the program is going to tell you, this is a cat, this is a dog. And the beautiful thing is you can also get those details, those answers with a level of confidence. So you can get, for example, this is a cat, and this is my 90% guess that this is a cat. Or this is a dog, and my guess is 65%. So that really works out well in production environments because you can even have certain thresholds So imagine you work in an environment where you say, if I'm sure, let's say if I'm 60%, oh, let's say if I'm 80% or more sure that this is a cat, go ahead with my logic. If it's less than that, I'm gonna send it to some human out there that's gonna add, more value to the process. So the ability to have confidence score is really a wonderful item here. Okay, let's talk about all of these things now that we know what machine learning is. Now, this is what we call the, in my humble opinion, global map. So, artificial intelligence is really this big circle, and the idea is you want to have these machines act as if they have a sense of intelligence. You want them to act on their own. You want them to have motivation. You want them to have goals, and it becomes extremely philosophical if you think about it in that way. Machine learning is a subset of AI, and not a lot of people understand that. A lot of people use those things interchangeably, which is not always that cool. Machine learning is a set of AI, is a subset of AI that allows you to do that kind of intelligent work. However, it allows the machine to learn on its own. And this is extremely important in different environments where you have dynamic data coming in, when you have different things coming in. So you can't just write an if and else statement and you call it a day. You have to have a sort of intelligent mechanism in order to adapt, with the whole thing. Now, deep learning does things a bit different, and that is exactly the example that we shed some light on. The reason is you have to have a huge amount of data. You're relying on a thing that we call neural networks, and they're set up in a very deep methodology. And we're going to exactly explain what deep is here. But the idea is we're not using classical machine learning where there's a lot of emphasis on statistics. In deep learning, we're relying on a lot of calculus there. We're relying on a lot of basically gradient descent math. We're relying on a lot of, let's say, algebra in order to get those things working. Okay, so if I had to really summarize it, I'd say that machine learning, as of today, is simply glorified statistics and math. And a lot of people don't really appreciate that. But the honest truth is, machine learning, even though at its core, relies on math and statistics in order to do those kind of predictions with those mathematical tricks and algebra stuff. And the reality of it, machine learning as of today, the way it's presented, is not strictly just talking about those statistics, and those mathematical items. We built a plethora of tools. We built a complete ecosystem that somehow surrounds this sort of thing, and it gives it value. So we have new tools coming in to help us on those things. We have different methodologies, different architectures for setting up neural networks. So it gets very complicated as you grow. But at its core, machine learning is strictly glorified math and statistics, as everything else in the world. So this is basically the status quo for machine learning. So this is, where we stand and the things that really change the whole landscape for all of us. Now let's talk about technical problems in order to appreciate what we're doing here. You see, the first thing is what we call classification. And with classification is classifying data points to distinct classes. So that example that we had about cats and dogs is a great example for this idea that we call classification. So you have data and you need to classify it to different classes. Is it a dog? Is it a cat? Is it a human being? Is it a light? Is it a phone? So all of these questions here, they can be answered when you build a classifier. And classifier is, as we said, a machine learning model that can tell the difference between classes. And that works with images. It works with tabular data as well. So if you have raw data, if you have different things, that really works as well. A great example for that, for your information, if we're talking about spam and ham. So we understand that the email world is crazy. You get a lot of spam every single day. And all these spam emails come in for different purposes, but how can we really tell if this email is spam or is it really legit? What we can do is we can rely on a classifier that realizes that uses machine learning in order to feed all of these examples into the classifier, and by the end of it, it's going to know the difference between those two. And now you probably now know why on Gmail, for example, or on things like Outlook and all of these email services, you get a small box that says, this is a spam. This is a legit email, not a spam. And when you do that, you're basically training that machine learning model to get better and better, in its accuracy. And when we say train, we mean that we're taking all of these images or data points and we're putting it in the model so the model can adjust, okay, or the neural network in that case. So when you hear me say training, I mean exposing the model to the data that we have, okay? So this is a great use case to tell the difference between spam and him. And we actually use that also in the financial world. So in the financial world, you have a lot of legit transactions, really horrible transactions happening, people stealing credit cards, and all of these bad things. And so to identify fraud and to identify legit things, you won't be able to actually do it by hand. It's extremely difficult. People tried to do it in the past. It did not work that really efficiently. But with machine learning, it's just getting that data and but believe me when I tell you that banks have a lot of data on it. They store every single thing that you do. Every time you swipe your card, every time you do something with your card, you pay online. They got your data, and they have the ability to really train those sort of neural networks in order to give them that sort of practical use cases. But that works because they have your data, and you gladly give it to them. And so if we're talking about features here, and you're gonna find those two words like very commonly in the world. So features are the kind of input data that we want to give to the machine, and we want it to give us the verdict, or in this case, the output. So imagine I give the machine learning. So the whole purpose of me doing such a legit case is to understand if this transaction is fraud or not fraud. In order to do that, I'm going to supply what we call the features, all right? And I'm going to supply with it my labels. So the label is the output, the correct output. So when I say this transaction here, as you can see, all of this is a single transaction, resolves a non-fraud, not a fraud transaction. The next one, though, is a fraud transaction. So when we take those examples and we feed them in one by one into this neural network, by the end of it, this neural network is going to get so smart that it's going to know exactly how to tell the difference between fraud and not fraud. In order to experiment with that and really try it, what we can do is we can take an example, but not from our training set, from a different set of examples. We can take those features and we send it without supplying the verdict. And by the end of it, the machine learning algorithm, because it's so many examples, it has seen so many examples, it can now tell the difference between a legit transaction or a fraudulent transaction, which is extremely cool because you don't have to do it manually. It happens directly and automatically. So cool, right? And the beautiful thing now is that you've got different machine learning communities, and a lot of people work in that sort of area. So you have basically Kaggle.com, which is a cool community for machine learning engineers, people that want to do this sort of work. And it is so awesome because when people solve problems, you get to see how they fixed it and the kind of tools, the kind of tricks that they've done are to train the data, get it up to speed, and how to exactly solve certain problems. So Kaggle is really cool. Make sure you register in it. And remember when I talked about this black box that I said is machine learning model, is basically a neural network. So a neural network is basically this sort of design, this sort of thing that takes inspiration from the human mind, as if you have actual neurons on your mind, for the people who study neuroscience, we're trying to mimic that, and we're trying to build a sort of digital form, let's say, digital replica of that design in a way, taking inspiration from biology as always. And then when you build something like that, believe it or not, it actually works. It gives us a very close result set to the real thing. So when we talk about neural networks, it's strictly a sort of a design, and you can see the code here using a Python library that we call Keras. Keras is now part of TensorFlow 2.0, and TensorFlow 2.0 is this machine learning framework that almost every engineer in that space uses, okay? So a neural network is this design that allows us to really tackle certain problems. And it's important to say that in this current state, machine learning is not your go-to answer for everything. And that is the horrible truth. So certain problems have to have different designs in terms of the architecture. When you want to build this neural network, this sort of black box that you can feed it in with data. For speech, for example, you have to have things like LSTMs. You have to have RNNs, sometimes CNNs if you're smart. Visual stuff sometimes uses visual stuff sometimes use CNNs or convolutional neural networks. So we have a plethora of tools, a plethora of architectures that you can design your neural network or your black box before you feed in data. All right. So the ultimate goal here that I want to get to you guys is that there is no one size fit all. Everything is different. Every certain problem requires a different set of designs, different set of architectures. Okay. And when we're talking about data, as you remember, it's the idea of feeding not a huge amount of data into that neural network that we just designed with a couple of lines. And then by the end of it, we just got to wait for the machine to show the examples to the black box, so the black box can learn on its own by observing the examples, and then it can understand what's wrong, what's right, and all these things. So training a neural network is basically the synonym for showing a lot of examples so people can solve the problems that they have. Okay. So this is an example taken from basically Colab, which is a tool by Google that allows you to experiment with Python online, which is so awesome. Okay, so training a machine learning model, doing these sort of things is just half of the issue. The other half is you need to deploy your work by the end of it so people can actually use it. So we've seen that part here, building the model. We've seen that you have a neural network that you either can code with or you can use the cloud for, and then you have to have your label data. And when we talk about label, we mean we have to have a data that has features and labels, because this sort of supervised setup really requires us to give examples with previous answers to the machine so it can learn from. Okay, so we're not depending on the machine to know everything on its own. We're giving the machine examples of things in the past so it can learn from past experiences, if you want to say that. And so that part, building the model, is something that we're done with. But in the end of it, you want to deploy, right? And sometimes deploying really differs from one platform to another. So if you want to build something that has access to the cloud, you have the luxury of using the internet, you want to use something like the cloud. Yes, and that works. So the cloud is one of the hot places where you can deploy. But there are cases where you don't want to deploy in the cloud. You want to deploy in a machine, let's say in a microcontroller. You want to deploy, let's say, in a microprocessor, or let's say the Raspberry Pi. All of these great examples. And you might ask yourself, now, why would I do that? Why would I go there if I have internet? And the harsh truth is sometimes you don't have internet access. If you go to rural places, and I'm sure in India you guys have that, you have a lot of that as well. You have certain far places that you don't have access to, maybe even electricity, let's say, or it's hard to get electricity, let's say, it's scarce. Having those sort of deployments for these really important machine learning models to be deployed on microprocessors or microcontrollers is really a good choice, because you don't rely on the cloud. Okay? So let me show you a couple of use cases so you can appreciate what you're getting here. So sentiment analysis is a great example if you're doing business. And a lot of people want to know if their customers are saying good things about them, if they hate their work. And so to do that sort of a thing, sentiment analysis comes into the picture. Sentiment analysis allows us to go over, let's say, imagine you have a lot of tweets coming in, and a lot of people have hashtags next to them. You can basically get those hashtags using the API at Twitter, and then you can feed them into this model that can classify them into positive feedback, negative feedback, or neutral. And this can also happen in real time, which is amazing. You can do that with Spark, Apache Spark. You can do that with Hadoop if you want to do it in terms of, let's say, batches. But the idea is you can get that work done, and you can do those sort of classification workloads really extremely fast and at scale as well when you have that sort of model methodology working for you. Regression also is a different kind of thing. So we're not talking about classification now. Classification, as we know now, that we can tell the difference between classes. Regression, on the other hand, is having a specific guess in terms of numbers. Let's say speculations from a continuous, variable, basically. So imagine you have something that changes depending on certain factors, and you need to have that specific number, found. You can actually do that. So a great example is housing prices. Now, if I want to go to a house and I want to guess the right price, I will definitely do it by experience. But if we're talking about machine learning, it can really ease the job. Reason is, You can show it a lot of supervised examples, labeled data, and you can give it past data that, hey, this house is worthy of 60, let's say, whatever currency, or that house is 120K, that kind of currency. And so with that, you can show it to the machine learning model. It can get better and better and better. And by the end of it, that machine learning model will be able to guess on your behalf, which is so, so, so cool. And that really works in real life, especially when it comes to housing prices. And don't get me started when we're talking about NLP and the magic of natural language processing, which basically the science and the discipline of understanding language in the machine. So text comprehension and generation, pretty important task for a lot of people. So we have this new called sort of architecture. If you remember from our neural network design, we have this complicated architecture that we call transformers. And that transformer design allows us to understand more and more and more about the text. So a great example is this machine learning model, which is a huge model and can be accessed on the cloud, that goes by the name of GPT-3, which was designed by OpenAI, the big business in artificial intelligence, and it allows you to talk to it and it can get you answers. So I had the privilege to talk to that machine learning model, and I was asking it about capitalism. I wanted to hear its opinions on capitalism. And it was giving me a lot of answers that were really funny, but nonetheless, it felt like I was having a conversation with an intellect, with somebody who's really intelligent and somebody who's really well educated on certain matters. And before we go, I want to show a couple of notable mentions here. So Microsoft Azure is a great resource for that. They have a lot of demos that you can actually tinker with on the cloud, on the browser. So they have this service that they call Microsoft Cognitive Services. This catalog allows you to, for example, upload an image in their vision services, and it can get you a lot of, basically stats on the kind of image that you show. So you can see the smell of the person, you can see the gender, the age, the glasses, if they're on or off, if you have makeup. Thank God I don't have that. And a lot of cool things as well. And all of these things are actually accessible, and you can get them by having access to their APIs as well if you want to build programs directly using those. Amazon Connect is also an omni-channel cloud contact center. So basically, you can build a contact center that uses machine learning in order to tell if somebody's frustrated or somebody is really having a great time using your services and all of these things. Okay. So Amazon Connect is amazing. Now that we touched on supervised learning, classification, regression, let me talk briefly about unsupervised learning. The reason we call it unsupervised is that you as a human, you don't add a lot of supervision to the mix. You see, with supervised, like classification or regression, we had to give the right answers in the very beginning so the machine can understand from our experiences before it can really decide. With unsupervised, you're giving the machine this sense of basically telling it, just go on your own trying to fix things. So this example of gas that we showed you last time is really a great example for something that we call autoencoders, or basically, so autoencoder is this sort of thing that allows the machine to pick up certain patterns from data on its own, and finding that kind of structure sometimes doesn't need that sort of mentoring, let's say, and that sort of supervision. So GANs are a great example of doing such things. Also in autoencoders, you can even allow the machine learning model to behave as if it was a compression algorithm. So this is a great example of showing numbers in here and then asking the machine to regenerate those on its own. And so what is going to happen now in the machine learning model is going to have that sense of structure in how to structure data in this compression sort of thing. And as you can see here, it's not lossless, it's lossless. It's actually lossy, which means you're going to lose a lot of data along the way. So we have this sort of blurry thing, but nonetheless, it works. It's amazing that you can do compression by strictly just using machine learning model. So that has implication on the speed of the algorithm and a lot of stuff that we can use in practical life. All right, sweet. So let me just show you a small roadmap for the people who want to take this forward and maybe use it in their business and their own personal life. So adoption first is pretty important. So if you want to start in that area, remember that starting is easy. Starting in machine learning, there's a lot of stuff, a lot of details, a lot of books, a lot of videos, a lot of use systems that you can use, a lot of resources. But the idea is you want to really pick. You want to pick things in a, let's say, in a progression that it really works for you. So if you're a books kind of guy, make sure you have books. If you're a video and you want a video kind of guy, you want to have hands-on fast. You want to do that first. So everything is available, including the tools, by the way, but you got to be extremely smart about it. And the million dollar thing is you don't want to say that I just want to use machine learning and that's it. You want to have the right question asked before you get into that. Because asking the right question is the first thing in knowing if you really want to use machine learning to begin with. Because the ultimate truth is sometimes machine learning is not really the best chosen tool here. Sometimes it's an overkill to use machine learning. You can just get by using an if else statement and you're good to go, if you can believe that. So yeah, not everything is a silver bullet. Sometimes it's just an overkill to use that sort of thing. Remember that, especially for the engineers out there, the machine learning engineer, they might not like that, but that is the honest truth. Sometimes machine learning is just an overkill for the task that you have at hand. Okay, so if we're talking about everything that is available, just remember you choose the right architecture, the right basically cloud to use, the right tool, the right programming language, the right framework. So a lot of things are there, but you have to be very careful when it comes to choosing. And especially if we're talking about neural network architectures, not every architecture is going to do the job that you have. So if you want to do speech synthesis, speech recognition, you got to rely on specific architectures. If you want to do, let's say, you want to generate certain faces, you're going to use different things. If you want to do time series prediction, you're going to use different things. You have autoencoders as well. You have a lot of stuff. So pick exactly depending on what you have. And remember that the open source community is just freaking amazing. The community is extremely generous. Everything is almost there for free. So rely on that. And don't forget, the biggest machine learning things are already public. Now, TensorFlow, for example, one of the great frameworks now that are available for all of us, the same tools that are being used within Google, within those big corporates, that you can now use. Keras, which was an interesting Pythonic library, is now part of TensorFlow because it was so good when it comes to allowing people to build neural networks with ultimate ease. OpenCV for computer vision, PyTorch by Facebook, NumPy and Cafe, and there's a lot of stuff that are just for free that you can use. And if you're really picky about building things and you don't want to get your hands dirty from the get-go, you can always use cloud providers. AWS, Google Cloud Platform, Azure. They're just amazing when it comes to experimenting before you do that. And if you're into Amazon, SageMaker is out there. It's a complete platform that allows you to do all that work together with no headache. And if you don't want to get your hands dirty also, if you don't like AWS products, Google Colab is amazing. You have this you have this Python environment. It's really close to what we call a Jupyter notebook if you're coming from data science backgrounds or if you're coming from machine learning backgrounds already. So you get this whole thing in this one single space. You have the explanation and the actual demo and the code. So it makes it very easy. Now with Colab, you get all of it on the cloud, which means you don't have to install anything on your machine, which is pretty straightforward now. And if you're really crazy about keeping the data at your machine, you're kind of picky about putting stuff on the cloud, you can also use Colab engine in order to interface with your local runtime, which means if you have a specific, let's say, Jupyter Notebook interface here that relies on your hardware or something like that, you can actually use that experience from the cloud, but everything is going to go through your local machine. So your data is not going to go on the cloud for the training. You can do that as well using that certain option here, which is connect to a local runtime. So in summary, before I leave you guys, make sure you get a good data set, clean it, make sure it's ready for training, because not everything in life is straightforward. Sometimes you have to do a lot of work and clean stuff before you do the actual work. 2, build a neural network, choose the right architecture. Remember, not every architecture works magic. It depends on the problem. This is why artificial intelligence still needs us as humans to get things working. Third, train the neural network. Make sure that you're happy with the accuracy. So it's a back and forth sort of exercise. If you're not happy with those accuracies that you got, make sure you tweak a bit. You change your data set. You have enough data set basically elements. And last but not least, deploy in the right target. You might want to deploy into APIs that are exposed online on the cloud. We're going to deploy as certain APIs that are mapped into microcontrollers. So pick your target really well. Now, in terms of risks, because not everything is really clean in this world, machine learning is data hungry, especially deep learning, which means you're not going to get very far if you don't have a huge amount of data sets. Uh, I've seen a couple of defining demos, but yes, generally speaking, you need a lot of data in order to build proper machine learning models. And that is sometimes extremely hard for businesses. And also, let's not just overcome or just forget about those ethical issues that are very apparent when we're talking about acquiring data, the ethical stuff. Is it okay if I steal your data to build a model? Is it okay to really infringe your privacy in order to do those things? Very open questions, but the answer is sometimes, most of the times, it's just unethical to do those sort of things. But a lot of businesses go for that in order to get things done, as you know, from, let's say Cambridge Analytica and Facebook or now Meta. And generally speaking, you have a lot of stuff and difficulties when you're working with machine learning. When you want to scale your solution, you want to ask about talent. Integration is not easy. Privacy is a pretty big deal. Bias also is a pretty big deal now. So not every data set is going to be worthwhile if you're working with it. Sometimes it's just biased towards a specific sample set, sample space. You have security as well. So all of these things are important to look at if we're talking about building the right machine learning model. And with that said, so I want to leave you with that certain code that I have, which is in the race of business, data can either make or break your business. Just put that in mind, especially for building businesses. Always have your business revolve, around that data pillar in order to build really important stuff. And if you really enjoy my session today, I want you to just basically check out my talks on YouTube. I have a lot of stuff on building machine learning models, on building game engines, doing reverse engineering, and a lot of stuff. And yeah, I hope you guys enjoyed it. Thank you so much for listening. I'm not sure if we have questions, but I'll be here for questions. Yeah.
Thank you, sir. Thank you for this informative talk. Hello. 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 Am I audible?
So, do we have any question, guys? Anything from your end? Anything that you want to ask about, or everything is clear for you guys? So, any questions? Well, that is it for you guys. No questions then? All right then. So
Yes,
I'm
sir.
guessing.
Sorry. Yes,
Yeah,
sir.
go for it.
Uh, sir, there are no questions. Uh, thank you, sir, for such an informative talk.
Sure thing.
For being with us here today. Thank you for joining us, everyone. Hope you all learned something and had fun, cause I did. Thank you so much, sir.
Thank you so much for having me, and have a great day. Take care, guys.